Good morning student friends. In this video, first of all we will see one video based on hand forging, machine forging, cold forging, hot forging, impact forging and press forging. First of all we will see this video.
When does forging not involve fraud? When you're talking about metal. Many industrial machines contain steel parts that have to withstand great stress. The metalworking method that produces the strongest steel parts is forging. Heating the metal, then forming it to the required size and shape. Steel forgings are made from scrap iron. Pieces of used iron recovered from demolished buildings and old cars, as well as bits of new iron left over from the manufacture of iron products. Forge workers maneuver a gigantic magnet to lift almost 6 tons of scrap at a time until they filled a 28-ton scrap bucket. The bucket empties 2 such loads into a fiery furnace whose temperature peaks at 3,000 degrees Fahrenheit. This is called an electric arc furnace because the heat is created by a strong electric current running in an arc between 3 electrodes. There are about 20 main grades and 100 subgrades of steel. They're produced by adding specific metals or non-metallic chemical elements such as aluminum, nickel, chromium, vanadium, manganese, carbon, and molybdenum. They also add the mineral fluorite to help fuse the metals, some of which are in the form of blocks called ingots. Throughout the 3.5-hour meltdown, they test and adjust the chemical composition. They try to attain the lowest hydrogen, oxygen, nitrogen, and sulfur levels, the key to producing strong, high-quality steel. Then they pour the sizzling molten metal into a 50-ton ladle that's lined with heat-resistant brick. They add aluminum and lime to chemically counteract oxidation, rusting caused by air exposure. Now they cast an ingot, a block of steel that they'll shape into a forging. The molten metal flows out the bottom of the ladle into a mold below. This bottom pouring, as it's called, makes for a smoother casting because liquid flowing downward doesn't swirl around as much as liquid poured sideways. This forge can cast ingots weighing up to 46 tons. After several hours, the ingot solidifies, and they turn the mold upside down to extract it. Then, over 12 hours, they reheat the ingot to 2200 degrees Fahrenheit. This makes it soft enough to hammer or press into shape. To make large forgings, they use a machine called a forging press, mounted inside a forming die or a pair of dies, depending on the technique they're using. The press applies thousands of tons of pressure, crushing the ingot and forcing it against the die. The steel is quickly oxidizing with all this air exposure. They use a high-pressure water gun to remove the scales of rust. An ingot often passes through a die several times or through a series of dies arranged in sequence. Each pressing forms the metal bit by bit into the final shape. Metal is composed of microscopic crystals. Squeezing it in a press bends these crystals, destabilizing the metal structure. But reheating the metal creates new crystals to replace the deformed ones. This restabilizes the structure, and because the new crystals are smaller, makes the metal stronger than before. That's why finished forgings require heat treatment in what's called an annealing furnace. They heat for a day or two depending on the grade of steel. Then they soak in a water and chemical bath for about 5 hours. This strengthens the steel even more. Finally, workers mount the steel forgings on lathes and milling machines. They remove the rust scales that form during heat treatment, then precision machine the forgings into what the client ordered. Usually industrial parts such as rotors, spindles, and shafts. Many factories prefer to buy forgings in the shape of blocks or bars and machine the parts themselves.
Hello. Whatever video we have seen, in that video it has been shown that electric arc furnace, and here the arc is produced in between graphite electrodes and the metal charge. That's why it is called as direct arc furnace. We have seen the 3 graphite electrodes, they are intermittently striking with the metal charge and they are producing the arc. Now the metal is melted. In that metal they have shown the alloying elements are added, like a nickel, chromium, again cobalt, molybdenum, silicon, manganese, sulfur. All these are the alloying elements. They are added in required proportion. Afterwards, after getting required temperature and chemical composition of that melt, it has been taken out into the pouring ladle, and that ladle is taken to the pouring station, and pouring is carried out in one of the die which is having a circular cross section. And after solidification, and the material is in the plastic stage or in the red hot condition of that material, it has been taken out and it is directly taken to the open die forging. And here by using that open die forging, the pressing on that circular cast part has been performed, and it is converted into the slab, and that slab is now taken to the milling machine so that you can remove the surface irregularities that may be the oxide scales. This is the video in which combination of continuous casting with the open die forging has been shown. Now second video we will see, that is impression die forging. impression die forging. We have seen this open die forging as well as closed die forging. Closed die forging is also called as impression die forging. Now next part is the forging operation. Few of the operations we will see here. First is upsetting operation. See in the figure, lower die it is a stationary attached to the anvil, upper die is continuously moving about y-axis or about vertical axis, and in between that we have to compress the workpiece. This yellow color is a billet. You can see the dies are flat, that's why this is called as open die forging. This upsetting, this is the operation of reducing the height and increasing the width or the cross sectional area of the workpiece. You can see here in the second case, plastic deformation of that billet has been taken place and its length has been reduced, its thickness or the cross section area has been increased, and this is the product. This is the upsetting operation. In this process, the height decreases and width increases proportionately, that is cross sectional area increases. This is the upsetting operation. Opposite to the upsetting operation is the drawing down operation. In this process, length is increasing and its diameter decreases. Length is increasing or its diameter increases. This is the drawing down operation. It is opposite to the upsetting operation. Now we will see the video on this upset forging. So this is the animation of upset forging. Manufacturing of the head of the bolt is the example of upset forging. Here cross sectional area has been increased and proportionately length has been reduced. Okay, we will stop here. In the next lecture we will see another bit.